So let's start on with the final. Is my whiteboard visible to everyone? Okay, health issues. Okay, fine. So let's discuss the triple trouble problem because it is very important. So let's discuss that. Guys, so today this particular like bit manipulation is gonna be over. So what topic you want to take up tomorrow? Like you want to take up tries or you want to take up something else? I am open to every topic you want to discuss. So like the topics which you want to discuss, which has not been discussed, not like the DP, because I can't give you more questions on DP until and unless you don't practice. Tries, okay, after that, because try can be covered in a day. Okay, so here, if you see, you have to figure out that all the numbers are present at 3 times except one number, and you have to identify which number is that, right? Triple trouble problem says that. So in this specific problem, you can apply the brute force, obviously. Like you can store it in a map and then you can identify, okay, the number which has frequency equals to 1 is the unique number and you can print it. That is the brute force you can think of right now. But what will be the optimized solution for that? Even you can think of a solution like brute force solution where you do not use extra space of map and just try to do the solution without the help of any extra space. I'm not gonna give you the solution, but you can think of that solution. So coming on to the optimized solution. So I'll just, whatever your array of n is, I am just gonna write the bitwise coding for that. So that is, it can be written as like this. 5 can be written as 0101. 3 can be written as 0011. 8 can be written as 1000. Again 1000. Then the other can be written as 1010. Then 0011. Then 0101. 0101 and 100. Okay. So now the thing is how you are going to get the answer of your particular problem, right? Do you find any, what I can say, the common thing here? As of now, no. So what you can try to do here, you can go bit by bit. That is, this is your 0th bit. This is your first bit, second bit, and third bit. Same goes with all. So if I talk about the 0th bit, okay, which of the numbers are there in the array which have their 0th bit as set bit? Can you tell me that? In the given array at the 0th bit, okay, which are the numbers 3 and 5. So if I'll see the frequency, it is coming 1 time, then 5, then 3 again, then 5 again, 3 again, and 5 again. Okay. What are the numbers whose 0 bit is not set? Whose 0th bit is unset? Obviously, you can see it is 8 and 10. Right now. So here I'll keep 8, 8, 8, and 10. Now, since you know the numbers are present in like triplets or 3 times, what you can do, you can find what are the numbers whose first bit, sorry, I mean, who has said bit or has one in the given position and which has unset bit. Okay. So the numbers which have set bit are total frequency of 6, right? And the numbers which have set bits, or sorry, which have unset bits, has a total frequency of 4. Yes or no? Are you guys getting this? So if the numbers are present in triplet, by any chance, if we do the mod with 3 here and we get 0, it indicates that you do not have your unique number in this position. Yes or no? And when you do mod here, 4 modulus 3, you are going to get 1, which indicates that the unique number which you are trying to identify is present in this list. Yes or no? But you don't know that specific number right now. Correct now? So now you can see in the 0th bit, this is the unset bit. So in the unset bit, obviously it's 0. You can't do anything right now. Now we will move to the first bit. For the first bit, if you will see, how many numbers have like set bit for the first bit and how many has the unset bit? Yes, guys, can you tell me what are the numbers which has set bit and what are the numbers which has unset bit? Okay, let me lower it down a little bit so that you can see the numbers, if not bits. Yes, now I think you can tell me. If I see in the first, for the first bit, I guess 3 is the only number which has the first set bit. And if I look towards 5, it do not has. If I look towards 8, it do not has. Again 8, again now it's 10. Sorry, 10 has a set bit, my bad. And then moving ahead, 10 has, then 3 doesn't have, 3 has, sorry, 3 has already been put. Then 5 does not has, 5 does not have, and 8 does not have. So now if you will see, you will get here the count as 4, you will get here the count as 6. When you will do the mod here by 3, you are going to get 1. When you will do the mod here by 3, you are going to get as 0. If the bit is set, that means there is some value which you need to add to your answer, right? Previously it was 0. That means you need not do anything as of now. But if it is 1, you need to do some process, and that is whatever, like you take initially your answer as 0, and later on you can do here answer equals to answer plus 2 to the power of I. That means if your bit, that means the first bit is set, you will add to your answer 2 to the power of I. That is, you will add to your answer 2 to the power of I is 1. You will add 2 to your answer. Clear or not? Similarly, when you will check for the second bit, you will get to know that, see, this is unset, right? So need not do anything. When you will check for the third bit, you will see that this is set bit. So you will add 2 to the power I, that is 8 now, because it will be the third bit. 8 will be added to your answer and you will get your answer as 10. So in this specific question, you are finding out your answer bit by bit. If the bit is set, you are calculating your answer, and if the bit is unset, you are not calculating your answer. Everyone, are you getting the approach and the thought process which I'm trying to explain?
No, actually I have one doubt. In the first in the zeroth bit, the unset, we are also checking the mod of 3, and if it is odd, then we are considering that number.
Yeah, we are considering that number, but if the bit is, see, this is a group of unset, like these are the numbers which
Yeah,
has unset bit in that specific position, right?
correct, correct. So
So
our
does
approach.
unset bit add anything to your answer? Like 0, does it add anything to your answer?
What do you mean by that? I mean, I'm thinking that zeroth bit, by just by that knowledge, we can conclude that answer could be 8 or 10.
No, but how will you know that it is 8 or 10?
Because
Again, you have to loop.
no, so because we know that there are only four numbers, and so the culprit is one of the four.
See, Vishnu, the thing is, your analyzation is purely based on the current question I have given.
Okay.
Your analyzation is not going beyond four numbers where you could have 10 to the 5 different numbers or 10 to the power 3 different numbers. What will you do in that case? Like right now, you are having these four numbers here. But what if these numbers are not only four, there are hundreds or thousands of number here? Then what will you do in that case?
So, ma'am, in that case, what I'll do is I'll pick up on that group of numbers out of the two, which has one unique, one different, like mod should be one. Why I'm saying,
Okay, go further.
so why I'm thinking that even if it is 1000, so 500 would go in one, and another 499 will come, because 3, whatever is mod 3, and that means it is all useless. Or those which are not mod of 3, that is where the number, my number lies.
I got it, but what
Mhm.
are you going to do further? I got your zeroth bit part. You told me that you are getting four numbers. Fine.
Yeah.
What will you do further to get your answer as 10?
So then I will only do the first bit for those group of numbers whose mod is 1. So here we just have two numbers like 8 and 10. So I'll apply the first bit for only that two numbers.
Perfect. Now, so you are telling you are going to separate from here.
Yeah, like binary search will ignore where the numbers are like not there.
Okay. And wait. Is there any case which will fail in this particular situation?
I don't think so, because we are all grouping based on 333, and there is only 3 or 1. So any multiples of 3 should be ignored.
Okay, so let me just give you here 6, 6, and 6. Now, what will you do?
So I'll just concentrate on 8, 10, and 6.
Then,
then again I'll go for the first bit separation
Mm-hmm.
between 8, 6 and 10, and I will see that only um, first bit I'm just thinking that only 8 and probably 6.
This may work out. The solution seems to be fine. You can
Yeah.
try implementing this solution. I guess this is on Lead Code probably and on the HackerRank as well. So this seems to be working out. You can try this out.
Okay. So I was also trying to think that you are also going in that direction, but
See,
I'm
my thing is I am constructing my answers from the bit. That is wherever zero is there, I need not add anything to my answer. And wherever one is there, I'm getting the set bit. There I am adding 2 to the power of whatever my current bit is. So what it will do, like you know that bitwise number is constructed this way only. If that where whichever bit you are in, if you want to convert it to the decimal number, it's basically 2 to the power of I added to your answer. So I was trying via that approach.
oh, okay. Please continue. Like
No,
I,
but it's done. But this solution seems to be fine, well, like working. So you can try it out.
ma'am, I could not follow the 2 to the power I. Like, so if you um, like, if it is at the first place, then how you conclude with 2 to the power I?
If it is at the zeroth place, it is 2 to the power of 0. That is 1 will be added to your answer. If it is 2 to the power of like 1, that means first bit is set. That will add 2 to your answer. And you know that if you have seen 011 is a binary, like binary number of 3. So
Yeah,
this bit is set, this bit is set. This will add 1 to your answer. This will add 2 to your answer. And overall, you're going to get as 3.
3.
Clear? And
Okay,
as you increase further, every time it is like 2 to the power of whatever bit you are in currently.
okay. So it will sum up from 0 till nth digit.
Yep, correct.
Okay, now I understand. Thank you.
Sum up from 0 till nth bit, but do not consider the unset bits. Ignore them. So next problem is you have been given array of n numbers. The numbers are 4, 7, 5, 8, 1, 3, 2, 7. So this is basically an array which consists of numbers from 1 till n. Like if the size of this particular array is so this particular array size is 8. So it should constitute the numbers between 1 till 8. Okay, so in this given array, you can see from like between 1 to 8, one of the number is repeating and one of the number is missing. So you need to figure out, like you need to find out which number is repeating and which number is missing. Clear? Sorry?
I
Which
don't see any. I don't see any repeat in this array of n.
7?
Oh, oh, okay, got it, got it.
Yep. So I will give you this as an homework. You can try this today, and if you have any issues or problem with this particular problem, you can ask me tomorrow. Okay, make sense? Or do you want more hint on it? I can give it. And one question I may have discussed in the class, or I have discussed in the class, but I'm not sure if you remember that.
Ma'am, the hint for this one is like I'm going to approach the same way, like from zeroth bit till the first second bit, just like how we did for the triple trouble.
But
The
don't try to repeat, like you can go via that approach, but don't always get stick to the same approach, because like if I'm discussing some questions in the class, they won't be having the repetitive approach.
okay, got it.
So my next question is, you have been given an array of n numbers, that is 5, 3, -8, 10, 18, -3. Array indexes are 0, 1, 2, 3, 4, and 5. You have been given k equals to 12, and you need to figure it out if there exists a subset whose sum is equals to k. This is the question. I have explained this question in the recursion, and yeah, I guess only recursion probably. And this is one of the question in the bitwise manipulation as well. Do you guys remember this question? Okay, perfect. So I want you to think of this particular problem in terms of bits if you can. And if you're able to come up with a solution, that will be well and good. Otherwise, I'll explain the solution for this. So would you like to try it on the first case is that question? Do you like to try this question? Yes, no? Give some ideas. Okay. So you can have how many subsets in an array of n size? Can you tell me? Two to the power n. Okay. So I'll just take an example here. You have an array. You have numbers as 5, -3, and 8. This is 0th, 1, and 2. Okay. So the total number of subsets this can have is 2 to the power of 3. That is 8. Now I will just write it. 0, 1, 2, 3, 4, 5, 6, and 7. I will write the bitwise manipulation for it. That is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and triple 1. Let me just reverse this. Let's start from here. 0. This is 0. This is 1. And this is 2. Okay. So now if if your subset is like 0, 0th subset. Okay. You need to check if any of the bit is set or not. Is any one of the bit is set? Is any one of the bits set in the 0 1? In 0 number, or for the 0 number, or for the
Mm.
0th subset, is any of the bits set?
No, no.
No. So you won't pick any number and you will get your result as 5. In the first subset, or like the subset with number 1, you can have 0 0 1. That means 0th bit is set, right? If 0th bit is set, the only number you can have in your subset is 5. Is 5 equal to k? Are you getting it?
5 equal to k, meaning 5 is not equal to 3. So
See,
3.
k, you can take any number. You can take k as 10.
Okay.
In this 2, you can see the first bit is set. So you will have -3 in your subset. In this, you have 0th and first bit as set. So you will have 5 and -3. You will find its sum. Here you have second bit as set. So you will have 8. Here you will have 8 and 5. Here you have 8 and -3. And at the end, you are going to have 8, -3, and 5. So you will find out all the subsets, and then you will find out the sum of each of them. And like whichever subset gives you the sum equivalent to k, you will return true. Otherwise, you will return false. Clear, guys? Are you guys clear with the hint? Okay. Do you want me to write the code for this? Do you guys want me to write the code for this? Okay. Give me a minute. Are you guys able to see my screen? Eclipse screen.
No.
Okay. Now are you able to?
Yes.
Okay, perfect. I'll take the small array only. Or let's just take the bigger one. No issues. So I'll pass array here, n, the length of the array, and k. These are the three things needed. Now we'll need to create the subset function. And you know that either the sum is possible or not. So the return type is gonna be Boolean. As you guys saw that we are like figuring out all the subsets, and the subsets are 2 to the power of n. So that means for loop runs from 0 and it is less than 1 left shift n. That makes it 2 to the power of n, right? For every I, you are running a loop from j equals to 0, j is less than n, and j plus plus. If by any case your, what should I check? Check bit, right? I need to check if the bit is set or not. Check bit.
Ma'am, I
Like,
have one doubt.
yep.
Ma'am, one less than n, which is the shift operator, it is 2 to the power n. I'm not very clear because n here is 6. No, do, char, 6. And then when we apply left shift operator, 6 into, like, it will become 2 to the power 6.
Yep.
Okay.
See, it is like, wait, I'll just, it's like if you have one left shift 6, right? So
Yeah.
it's like it's gonna make it as you have 1, 2, 3, 4, 5, 6. Okay, these are the sixes. If it shifted it for the one time, it makes it
Yeah.
1, right?
Yeah.
If it shifted it for the 2 times,
Yeah, 3 it becomes.
sorry, 0. Okay, like it is shifting only 1, right?
Oh, so 2.
Then
Okay.
1, 0, 0. Then 1, triple 0. Then 1, this
4.
0. So you know that the place where 1 is, its bit is getting increased and its value is like 2 to the power of I, which is 2 to the power of n. That is whatever your answer is gonna be.
Oh, I'm
Are
clear
you
now.
getting? Yeah.
Yeah, yeah, yeah.
If you have to check bit, then you have to see if I right shift J and sorry, 1. Why is it giving the error? Oof, why is it giving the error? Let me see it. Did anyone wrote the wrote the code for the check bit function?
It is correct, only I'm not sure why is it not working out.
It says that if your bit is 1, it's gonna return true, otherwise it's gonna return false. So if the bit is true, what you need to do? If it is true, what you need to do? Guys, don't just sit in the class empty-headed, no idea what to do and all. Every time you are making a subset, take a sum variable and make your sum equals to sum plus it will be array of j. Then every time after this is done, you need to check if your sum is equal k, you need to return true. Otherwise, the entire loop will run and it is going to return false. It is returning true. You can see 12 is possible. Yes or no? Is 12 possible? Guys, is the 12 number possible from the given array?
No,
How
no.
come it is not possible? Did you checked it? Did you checked it or not?
I'm still checking it. I couldn't
And
find it.
why are you saying it as no?
Because I don't see any way it'll add up to 12. 18,
Minus 3 minus 8. What will it become?
minus 11.
Minus 11 plus 18. What will it give it to you?
7.
7 plus 5.
12. Okay.
It is valid, right? Now let's give some very big value here. Let's keep it 50 and try to run it. It's not working, right?
Yeah.
So, did you understood this solution?
Yeah.
Perfect. So I guess I am done with bit manipulation from my end. If you guys have any doubts or concerns or questions, you can raise the queries to me. Otherwise, we'll start the try, or basically we'll finish the try by tomorrow. I'll pick some miscellaneous questions for 2 days. And if you have any other doubts or topics which you want that ma'am should discuss, you can freely come to me and ask me. I'll tell you. Okay, so guys, thank you for today's session and have a good day. Bye bye.
Thank you.